Okay, so we have two capacitors connected to a 400 volt battery in part A. They're in series. So here's your diagram. Here's what it would look like for part A. Part A, you got a 400 volt battery and then two capacitors in series. So 0.05 microfarad and then 0.1 microfarad. Now, the way you simplify capacitors, it's opposite of simplifying resistors. So if you have two capacitors in series, you do the 1 over equation. You're going to go like this. 1 over the equivalent is 1 over 0.05 plus 1 over 0.1, and then you simplify that down, and it comes out to be 0.03 repeating. 0.03 repeating microfarad. And then here's your 400 volt battery, like that. So, finding the charge, let's start with this guy. What's the charge on this simplified capacitor? So you're using the definition for capacitance. Capacitance is charge over voltage. So charge is capacitance times voltage. So what's the voltage across this capacitor here? Well, 400 volt battery means 400 and 0, like that. So we right at this point right here, we got 400. At this point right here, we got 0. So we have 400 volts across that capacitor. So you're basically going to be multiplying 0.03. So capacitance is 0.03, and I would just leave this in microfarad, because look, in fact, let me go down here. I need more room. So Q equals C delta V, right? C delta V. I would just leave the capacitance in micro. So that's 0.03 repeating micro. Now what's a farad? A farad is a coulomb per volt, and we're multiplying that by 400 volts. So the volts cancel and it comes out in microcoulombs. It's nice. You know what I'm saying? So this comes out as 13.3 repeating microcoulombs. So if the charge on this guy, just like resistors, if you find the current through a simplified resistor, you found the current through the original resistors. So the charge on this guy is 13.3 microcoulombs. The charge on this guy is 13.3 microcoulombs. Same logic as if those were resistors. Okay? So that's part A. Yo.
What are they equal?
The charges?
Isn't like
Well, okay. What, are you saying why do capacitors in series have the same charge? Because the way capacitors charge up, so let's say for a moment that this is not connected yet. So as soon as these capacitors, ready, we're going to hook this up, ready, set, connect. As soon as you hook up the capacitors, what happens is the electrons on this plate get pulled to the positive terminal of the battery. That leaves this plate positive, and then the electrons on the negative terminal of the battery get pulled up here. Actually, we have another. So the electrons on this plate right here get pulled over here because they're attracted to that positive, like that, which leaves this positive. The electrons down here get pulled up, which makes that negative. Basically, there's like a shuffling of electrons. The electrons all shuffle over, and the end result is that capacitors in series end up with the same charge on them. I don't know if I explained that very well. The electrons just kind of shuffle, 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 shuffle over. All right, let's look at part B. So part B, we put them in parallel. So we have our 400 volt battery. There's plus, minus. So we have 0.05 microfarad and 0.1 microfarad. Now this is going to be quick. What do we know about capacitors and resistors, for that matter, in parallel? The voltage is the same. And don't just memorize it, you should understand why. 400 volt battery means 400 and 0, so how many volts would we have right there? 400. How many volts over here? 0. So when you go across the top capacitor, what's the delta V for the top capacitor? 400. What's the delta V for the bottom capacitor? 400, because either path you take, you're going from 400 to 0, right? So finding the charge, so Q equals C times delta V. So we'll do this for the top capacitor, 0.05 microfarad. A farad is a coulomb per volt, and then we got 400 volts. The volts cancel, and we get 20 microcoulombs. And then you come down here to this guy, you do the same thing. So you go capacitance times voltage. So capacitance is 0.1 microfarad, coulomb per volt. We got 400 volts. Volts cancel, and we get 40 microcoulombs. So this guy has 40 microcoulombs, that guy has 20 microcoulombs.